Hey, moving on to example 4, same scenarios before. We first of all want to verify that we can actually do this problem, because sometimes you can't do the problem, right? And then does not exist, division by 0, move on to the next problem. So looking at this polynomial, and I suppose I don't really need to highlight the d theta. We have that, and we're going from pi over 6 to pi over 3. And just hopefully you've got these radian values pretty much under control from geotrig. But if you remember, 0 is here and pi over 2 is straight up. Pi over 6 goes about here, and pi over 3 goes about here. Pi over 6 is 30 degrees, pi over 3 is 60 degrees. So what we're dealing with is this specific region here. We're going from here to here. All right. Sine equals 0 here, and sine equals 1 here. And it equals numbers between 0 and 1 going through that first quadrant, right? And what we're dividing by is sine of theta squared. So if sine is 0, then sine squared is 0 also, right? So pi over 6, sine doesn't equal 0. All the way through to here, sine doesn't equal 0. So division by 0 is not going to happen here. So this is a legal problem. We can go ahead and do it. But again, always do that check first, because if this says pi over 6 to 2 pi over 3, 2 pi over 3 lives over here. Oh, we can still do that, couldn't we? Maybe if I said negative pi over 6, there we go. Negative pi over 6 to 2 pi over 3, then we're going to be crossing sine equals 0. Division by 0 happens, all of a sudden we can't do it. All right, so keep that in mind that we have that possibility on these, but most of them are going to be problems that you have to actually do. Otherwise they're kind of boring and the book would be, the homework would be too easy. We don't want to make that happen ever, right? Homework being too easy. So the next problem with trig functions is, we have 6 trig derivatives, right? Those are sine, cosine, secant squared, cosecant squared, secant tangent, and cosecant cotangent. Each of these 6 things has an antiderivative. So if you aren't looking at one of those 6 things, you can't antidifferentiate it right now. You can't integrate. You can't find the answer to that problem. So in its current structure, I can't do this problem. So what I need to focus on is, can I make one of these structures occur? And specifically, the ones that have squares on them are secant and cosecant. So I'm thinking that I want to go along these. So I'm thinking in my mind, since I see squares on those, that cosecant squared, secant squared, that's kind of where I want to go with this. Okay, going back to chapter 6 in the geotrig book, right? The trig identities, remember those? Our favorite thing ever, right? Everybody enjoyed those a lot. I enjoy those every year. But the purpose of those was that we're going to see structures like this, and we have to have the ability to know certain things about trig functions to be able to do some substitution and changing of things to make these structures workable, to create these types of things out of this type of thing. One of the tricks that we learned last year about any type of function is that if you have multiple terms over one term, if you have a multiple term numerator and a fraction, you have the ability to split that fraction apart into pieces. So if I break this apart into 1 over sine squared of theta minus sine squared of theta over sine squared of theta d theta, that is a legal step. Right. The reason I want to do that, here's one reason. Sine squared over sine squared is 1. 1's easy, right? Mm-hmm. That's one reason I want to do it. The other reason is I know in the back of my mind secant squared is the same as 1 over cosine squared, and cosecant squared is the same as 1 over sine squared. On our useful trig identity sheet last year, that was number 2, that was number 3, that was number 4 on those sheets. 1 over sine squared, notice is right there. There's a cosecant squared. That's creating that structure I want. Sine squared over sine squared is 1. That's another structure that's easy. So now I'm at a point, pi over 6 to pi over 3 of cosecant squared minus 1 d theta. Now I'm at a point where I can actually anti-differentiate this thing. Okay. The nice thing about this, granted chapter 6 in the geotrig book, the trig identities, some of those got pretty elaborate, these are pretty straightforward because there's only 6 structures you want to create. So you're limited to the number of things they're going to throw at you. Okay, but again, they're going to throw stuff at you that's going to require some skills from trigonometry. So once they get to this point, the antiderivative of cosecant squared is negative cotangent. Remember that cotangent goes to negative cosecant squared, so anytime you're antidifferentiating any one of these 6 and you get a co-function answer, we change the sign. So cotangent and then make it negative because we change the sign. Minus theta, and we're going from pi over 6 to pi over 3. Now it's time to evaluate. So I'm going to put pi over 3 in for theta first. I'm going to get negative cotangent of pi over 3 minus pi over 3. Then I'm going to put pi over 6 in. I'm going to get minus negative cotangent of pi over 6 minus pi over 6. Cotangent of pi over 3, cotangent of pi over 6 have exact values. I'd like the exact values when possible. Keep in mind they're going to be radical structures, but again, a radical structure is exact. I'd rather have that than a decimal approximation. So if I'm evaluating this, cotangent of pi over 3 is the square root of 3 over 3. And it's negative. We're subtracting pi over 3 from that. The cotangent of pi over 6 is the square root of 3, so negative square root of 3 minus pi over 6. And at this point, if I just get a common denominator of 6 times 2 times 2 times 2 times 2, we're distributing a minus sign here, times 6 times 6, so it's going to be plus 6 times the square root of 3. And that's already over 6, so minus pi. So altogether, we get 4 times the square root of 3 minus 3 pi.
Plus pi, right?
Oh, it's plus pi, thank you. Plus pi. So minus 2 pi plus pi is going to be minus 1 pi all over 6. So we have the ability to get that exact answer. I'm not going to count, unless it specifically says find the exact answer. If you give me a decimal approximation for that, I'll still count it right. But I'll challenge yourself to create these exact structures sometimes on these problems as opposed to just immediately going to your calculator. If you did want to go to your calculator to evaluate it as far as cotangent of pi over 3 is concerned, first of all I want to make sure I'm in radians because we're in radians, right? To type in negative cotangent of pi over 3, it goes negative tangent pi over 3 in parentheses and then negative first power. That makes the cotangent. The in parentheses has to happen. There's your negative square root of 3 over 3. See they're the same value right there, right? So, but again, if you wanted to get a decimal approximation, that's what would happen there, of course. So, but again, cotangent is just tangent of whatever in parentheses to finish the tangent instruction, and then the negative first power makes the reciprocal. So the cotangent specifically. But again, challenge yourself to get these exact structures. They're a little bit more challenging, require a little bit more of good algebra really to get from here to here correctly. So challenge yourself, you'll be a better math student because of it.